So these are the number of valence electrons that each one of these atoms has. So, or each one of these elements has. Go back and make sure that you are getting the right answer. And we'll move on. There's one thing while I was in break that I noticed on your learning objective sheet that I neglected to mention to you. The periodic table is set up so that the rows are called periods and the columns are called groups. And I kind of glossed over that. I apologize for that. So you'll notice that on your learning objective worksheet, you'll need to know what periods are. They're the rows of the periodic table and the groups are the columns. Okay. Now that we know about the octet rule and we know how many valence electrons each of our elements has by looking at their group number on the periodic table, let's take a look at how many electrons will each element lose or gain to fulfill the octet rule. Okay, so each one of our elements is going to need to do some work in order to get to have 8 electrons in its outer shell. Okay, so let's take a look at some examples. Okay, so the first thing that we need to do is identify how many valence electrons we have. Okay, so look at your periodic table. There are how many valence electrons in hydrogen? 1. In sulfur, 6. Gallium, I have to look up. 3. Carbon has 4. Lithium has 1. Chlorine has 7. Beryllium has 2. Neon has 8. Okay. So now we're going to, in the next part of our table here, we're going to need to figure out how many we're going to need to come to an 8. Now, in the case of hydrogen, it has only 1. It could gain 7 electrons, but gaining 7 electrons is almost impossible. That's too hard of work. So instead of gaining 7 electrons, hydrogen is going to lose that 1 electron. If you have 4 or less electrons in your valence shell, you can lose electrons in order to achieve 8 in your outer shell. If you have 4 or more, then you need to gain electrons. So we need to lose 1 electron for hydrogen. Sulfur, we're at 6. So to get to 8, we would need to add 2. Gallium has 3. So we need to lose 3. Carbon has 4. So we can either add 4 or take 4 away. Is that one that's in the middle. Lithium needs to lose 1. Chlorine needs to gain 1. Beryllium needs to lose 2. And neon is a noble gas that will not react, so we're going to put a 0 here. Now, the tricky thing is that when you subtract an electron, you're having a negative charge because those electrons are positive. So if you subtract an electron, your charge is going to go more positive. So then the charge here for hydrogen after losing an electron is not going to be -1. It's the opposite. +1. Because we have gained 2 electrons for sulfur, our charge is going to be -2, +3 for gallium. We can have -4 or +4 for carbon. We're going to have +1 for lithium, -1 for chlorine, +2 for beryllium. Neon's not changing at all, so it has no charge. So, whatever you're doing as far as losing or gaining electrons, your charge is going to be the exact opposite. This is a really important point that I want to drive home to you. Gaining electrons means that you're making your charge more negative. Okay. Now, if you go back and look at your periodic table, you'll see that there are the standard charges here. These standard charges reflect exactly what we just did. We looked at chlorine and saw that it was a -1 charge because it has to add 1 electron. Same thing for carbon. It can do either. Gallium, lithium, beryllium, and so on. So that's where these numbers, these standard charges come from. I'm not so concerned that you know where they come from. As long as you can write these numbers down here on your periodic table, you can use them properly. It doesn't matter to me so much that you get the whole octet rule concept, as long as you can use those numbers properly. Okay. We talked about why bonds form. Let's talk about the different types of bonds. There are quite a few different types of actual chemical bonds, but for our purposes, we're only going to talk about the 2 major classes. The first type are ionic bonds. Ionic bonds form when 2 oppositely charged atoms attract each other. Ionic bonds, ionic compounds, sorry about that. A better way to explain it. Ionic compounds are not called molecules. They are called salts. Ionic compounds are called salts. Just like table salt is an ionic compound. Ionic compounds are formed from 1 metal and 1 nonmetal. This is how you're going to identify ionic compounds. Look for when you have a metal and a nonmetal, that's always ionic compound. There is no electron sharing in an ionic compound, only electron transfer. All ionic compounds are solids at room temperature. So let's just take a look at how we can form some of these compounds. If we take sodium and chlorine together, how can we make a compound out of these 2 elements? Well, what we're going to do in an ionic compound, we're going to write down the standard charge for each one of these elements. So go back and look at your periodic table. And you'll see that sodium has +1 and chlorine is -1. It's really important that you know that we do not write the number 1 in charges. That's part of the convention of writing charges and elemental symbols. If it's plus 1 or minus 1, you just write a plus or a minus. So here we have sodium being plus 1 and chlorine being minus 1, and this is how it's written properly. So, in order to come up with a compound formula, we are going to take the number of each of these elements and we're going to swap them to form NaCl. Each of these numbers is 1, and that's how we get 1s down here. Do not write 1s. Okay, let's do another example that might be a little bit more obvious. Magnesium and chlorine. Look at the periodic table and find the standard charge of magnesium. Chlorine is minus 1. Now, to make our compound formula, what we do is we swap these numbers. Remember that empty circle just means a 1. So we're going to form the compound Mg1 Cl2, magnesium chloride. The reason we need to swap the numbers is because for a compound, your total charge of all of your elements in the compound must equal 0. And by flipping the numbers, you're going to have an equal number of both pluses and minuses to equal 0. We'll be spending a lot of time on this, probably in part 4 of the lecture, so don't worry so much if this is a little bit fuzzy for you. We'll be doing a lot of practice. The second type of chemical bond is called covalent. In a covalent compound, atoms are going to share electrons to complete their octets. Covalent compounds are called molecules. And they're made up of two nonmetals. Some examples are bromine gas. This is bromine in its elemental form. In order to have a full octet, you have to have 2 bromines. They have a single bond. Bromine's a nonmetal, 2 bromines, 2 nonmetals, covalent compound. HCl is hydrochloric acid. This is a covalent compound. Look at your periodic table. Find where H is. It's right here. What I want you to do is on your periodic table, I want you to circle hydrogen and write nonmetal right by it. Hydrogen is in fact a nonmetal, even though it is on the left side of the periodic table. You're not going to get into why. So, therefore, hydrogen is a nonmetal, chlorine is a nonmetal, hydrochloric acid is a covalent compound. Keep that in mind. Okay. Now, I just want to talk to you a little bit about polyatomic ions. So take a look at your pink sheet. On the side where it has the 2 columns, you'll notice that on the left are a whole bunch of ions that have more than 1 atom. Polyatomic means just that, more than 1 atom. And the overall charge on these things is not 0. So it's basically like a compound, that's charged. That's what makes it a polyatomic ion. So let's take a look at a couple of common examples. NO3 minus is nitrate. That's the nitrate ion. It's negatively charged. If you take a look at this polyatomic ion though, you'll notice that N and O are both nonmetals. It doesn't say, we're not talking anything about whether or not this is a covalent compound. This is just a compound that when these two elements form with this ratio, they're charged. The resulting compound is charged, which makes this whole compound an ion. I know that it's non-metal, which makes it covalent, but the whole thing is charged. That's what we call an ion. Don't worry too much about that. The best way to identify whether or not something is a polyatomic is just by seeing if it has more than one atom and then trying to find it on this list. This is a pretty comprehensive list for our purposes. There are some ones that are not on here. If for some reason on a homework you have something that's not on here, Google it and you should be able to find it. Okay. Now let's start talking about nomenclature. Okay. So now that we know the basis behind compounds and how they form, why they form, and the types of compounds that are formed, let's talk about how we can name these compounds so we all know what we're talking about. So chemists have determined this compound nomenclature, which is basically a naming system for all the different types of compounds that are out there. Each different type of compound has its own set of rules for naming. So I have a separate slide for each of those and examples to follow so that we can practice getting a hang of the different sets of rules. Okay, so the first thing that I want to talk about us naming is what we call cations. Cations are things that are positively charged. So when you're positively charged, that means that you have lost electrons. Remember that losing electrons means that you're losing that negative charge, so you become positive. So to name a cation, all you have to do is write the name of the element. The name of the element is what the name of your compound. For example, lithium, Li+, its name is the lithium ion. Same thing for H+. All cations are metals. Non-metals do not usually form cations. Anions are the counterpart to cations. They are the negatively charged ions, and their process for naming is a little bit more convoluted. You need to take the name of the element, remove its suffix, and add IDE. Let's do some examples. Here we have O2-. The name of the element of O is oxygen. And we need to remove the suffix. Because you're starting with a vowel here, the best way to find out where your suffix starts is to find your first vowel. And in this case, Y here acts as a vowel. Don't worry too much about the English about that. So we're going to take off here YGEN and replace it with IDE. So the anion O2- is called oxide. For nitrogen, N2-, we'll start with nitrogen. Find your first vowel and take off everything up to there. I should say first vowel from the N. And then you add IDE. So N2- is called nitride. Cl2-, Cl is chlorine. Work backwards and find your first vowel. Replace it with IDE, and you have chloride. Okay, I'm going to pause now and we'll resume in part 4 with the 4 types of compound nomenclature.